Good day, folks. Welcome to Bright's Mind Academy, where we bring brilliance to every lesson. In today's video, I want us to look at a vertical projectile motion, a type of question, hot air balloon specifically. So now we have a hot air balloon is moving upwards at a constant unknown speed. Okay, so remember when something it is moving at a constant speed, we know that the acceleration it is equal to 0 meters per second. But the acceleration of the what? Let me just specify this: the acceleration of the hot air balloon is equal to 0 meters per second squared. The acceleration of the hot air balloon. Is the hot air balloon in free fall? Automatically, the answer is no. Why? Because now remember, acceleration for objects that are in free fall, it is 9.8 meters per second. Acceleration, if you're in free fall, you will experience the force due to gravity only. But this one has an acceleration of 0. So therefore, you'll say no. Give a reason. Give a reason. Acceleration it is not equal to 9.8 meters per second, but acceleration it is equal to 0 meters per second squared. Or you can say it is moving at a constant velocity. Okay, it is moving at a constant velocity. You can say that as an answer because if you are in free fall, you are not moving at a constant velocity. Your velocity constantly changes with the same rate. Okay, your velocity changes with the same rate, like that. So yes, this is the most correct answer, squared. Or you can say not only gravitational force is not the only force acting on it. Remember, hot air balloon has that thing that causes it to go up. Okay. They tell us when the balloon is 200 meters above the ground, a small stone is dropped from the balloon. Okay. But now I want you to remember this: if there is a person here inside the hot air balloon and the balloon is moving at a certain velocity, whatever that velocity the hot air balloon is moving with, the person is also moving at the same velocity. Now if they drop an object that they drop, or a stone that they drop, was also moving with the velocity. Okay, so what will happen is that the stone that they drop will want to move upwards first. Why? Because it still has that velocity of the hot air balloon. Okay, so the initial velocity of stone A is the same as the speed of the hot air balloon. Why? Because now they were together initial. Like for instance, if you are moving in a car with a speed of 120. If you're moving with a car in a car with a speed of 120, if you brake, if you apply the brakes. Okay, what will happen? You will move a little bit forward. Okay, why? Because your body still has that momentum or the velocity that are moving forward. Okay, and it is due to inertia, because inertia says I resist change in motion. So inertia says, and now I'm still moving forward, but now you will eventually come back. Okay? So we'll go forward, stop, then come back. Okay, so this is what happens also. The stone is dropped, but now it will go upwards a little bit before it comes to rest at maximum height, then goes to the ground. Okay, yes. Therefore, another stone B is dropped 5 seconds later. So stone B is dropped 5 seconds later, T minus 5. Okay, for stone B, it is T minus 5 seconds later. Okay, from the balloon, while the balloon is still moving upwards at a constant velocity. Very, very interesting. Stone A strikes the ground at a speed of, let's say this is A. It hits the ground at a speed of 62.68 meters per second, whatever. Okay? Ignore air resistance. They say calculate the speed of the hot air balloon. How can I calculate the speed of the hot air balloon? Remember, I said the speed of the hot air balloon, you'll get it from the what? From the speed of the initial speed of the stone. The initial speed of the stone is the same speed as the hot air balloon. Okay. So now let's be in a position of saying, okay, I have initial velocity of A, final velocity of A. Okay, final velocity of A I have. Oh, initial velocity of A is what I'm looking for. Okay. Then final velocity of A I have. Then I have change in Y. I also have acceleration. So I'm in a position of saying, okay, let me use this formula that say Vf squared is equal to Vi squared plus 2A change in time. I'm going to choose downwards. Okay, upwards is positive. Why? Because they were moving upwards. Okay. When I do that, what is VF squared? VF squared, it is 62.68 squared. If I do not mix the 62.68 squared plus is equal to, do not say the initial velocity of the ball, it is 0 because it was dropped. No, that only applies when it is not a hot air balloon situation. But in a hot air balloon situation, it cannot be 0. Therefore, VI squared is what I'm looking for, plus Q acceleration is going to be negative 9.8 because it is acting downwards and I choose upwards as positive. And also the displacement, can you see my object is displaced downwards? Okay, my object is displaced at a distance downwards, but then I choose upwards as positive. So it means my change in Y will also be negative 200. Okay, yes. And now, then when you do your mathematical gymnastics, VI squared is going to be this number minus this number, then you square it. Then I'm going to have VI, which is equal to square root of 62.68 squared minus 2, minus 2 into negative 9.8 minus into minus 200, like that. Then I get a value that is very nice of 2.96 meters per second. Can I please conclude, therefore, speed of hot air balloon, it is equal to, I already wanted the speed of hot air balloon. The speed of hot air balloon, it is 2.96 meters per second. Now I move on to 13.2.2. They say to me, calculate the time it takes stone A to strike the ground. Time it takes stone A to strike the ground. So I have initial velocity, I have final velocity, I have change in Y, I need time. Okay, allow me to use a formula that is very, very easy, because this one here, change in Y, it has two variables, okay? So allow me to say I have final velocity, I have initial velocity, plus I have acceleration and change in time. Why am I using this formula instead of the one that has change in Y? Because it uses quadratic and you make a lot of mistakes. Choose upwards as positive. Final velocity is still 62.68. Okay, it is equal to initial velocity. It is 2.96. Oh, another thing. So here I'm gonna lose a mark. Why? Because now final velocity, can you see it is acting downwards? The final velocity is down, so it needs to be negative here. I need to substitute into negative. Why? Because now the final velocity, it is downwards, and then I choose upwards as positive. I'm sorry about that. Also here, when I come here, I'm gonna say final velocity, it is negative. Why? Because when it reached, okay, when it was going up, the velocity was positive. Again, but it eventually decreased and reached the maximum height. After maximum height, the velocity went down and in the opposite direction. Okay, yes, yeah, I'm sorry about that. But the answer will be the same, because either way, the negative, you squared it, but you lose a mark for substitution and you'll be out. Then plus acceleration, it is negative 9.8. I want my change in time. Okay, change in time is equal to what? Negative 62.68 minus 2.96. Then I divide that by negative 9.8. I get something like 6.697, which is the same as 6.7 what seconds. Okay. Fine. You can also use that one, this one here, change in Y is equal to VI change in time plus half A change in time squared. You will get now a T1 and T2. You'll get two T's. Why? Two times, because you are using quadratic, but one of them should be eliminated. Then they're saying to us, calculate the distance between the hot air balloon and stone B at an instant when stone A strikes the ground. So we want to know, okay, after 5 seconds, this ball was, let me use a different color. Let me try to come here. What is that? After 5 seconds, let's say the ball A was here. After 5 seconds, at time 5 seconds. Then what happens? Stone B was dropped. Okay? Stone B was dropped. If stone B was dropped, Leonard will do its trajectory like that again. But now, the velocity will be the same. The initial velocity will be the same. Why? because it is still moving in the same hot air balloon. Okay? So the initial velocity is 2.96 b. This also it is 2.96. But now this one will move at a time which is t minus 5. Okay, whatever time minus 5 seconds later. Okay, this one is for, it is for this one at time is equal to 5. We do not know. Okay, but what they want is what? They want us to calculate the distance between the hot air balloon and stone B after, okay, the distance between hot air balloon and stone B at the instant when stone A strikes the ground. So now, when ball A, when ball A strikes the ground, it is when time it is how much? At time it is equal to 6.7, right? So now I want you to understand it like this. This hot air balloon continues moving upwards. Okay, the time in which when ball A was 5 seconds later, it was still moving upwards. Okay, but when it reached the ground at 6.7, it was still moving upwards. But here, what we want it is the distance between what? The hot air balloon as well as the, okay, we wanted the distance between the hot air balloon and ball B when ball A reached the ground. So let's find the distance that that the hot air balloon traveled in 6.7 seconds. Why? We want the distance it traveled first. Okay, 13.2.3. Let's find first the distance that ball Y, so the hot air balloon traveled in 6.7 seconds. Okay, let's calculate change in Y for the hot air balloon at time is equal to 6.7 seconds. We want to know how far it is. Okay, so we'll say, okay, we'll use this formula. Change in Y is equal to VI change in time plus half a change in time squared. But remember, hot air balloon, it is moving at a constant velocity, therefore its acceleration it is 0 meters per second. If you do not remember this, you are out. Therefore, change in Y is going to be initial velocity of it is 2.96. Remember, it shares the initial velocity as both these objects. Then the time it is 6.7. Then change in Y that we get it is how much? We take 2.96 multiplied by 6.7. I get something like 19.832 meters. But now also, I want to know at this time now, at this time, where is the where is ball B? Ball B, we know when object A is here at time t5, it is at an instant where it was dropped here. Okay? Therefore, as ball A was moving downwards up to reach the ground, you now was somewhere here trying to go to the ground. Okay? So it means now we will say, okay, the time it spent when this one was at, when ball A was at the ground at 6.7, this one was at the at on A, was on A, right? With how much time? Time of whatever this time minus 5. Remember, whatever time that you have for B, we have to subtract 5 because it is 5 seconds later. Okay, so we'll say, which is how much? 1.1.7. We'll say, okay, let us calculate now change in Y for the what? For ball B at time 6.7 minus 5, because we cannot use 6.7 because at 6.7 it is the time in which the ball A hit the ground, but we need to minus 5 so that we see the time in which ball B was still on A, with which is equal to how much? 1.7 seconds. So we'll say, okay, let us calculate the change in Y for that one. Okay, the change in Y for that one is going to be change in Y is equal to VI change in time plus half a change in time squared. Now, I forgot to say, okay, examiner, my choice of direction, it is upwards as positive. Here, I'll also say upwards as positive. And this one, it is the ball B, and it is in free fall, okay? Change in Y is going to be equal to, initial velocity is the same for all of them because they are moving from, they are all from the hot air balloon. So it is 2.96. Change in time, very, very important to use 1.7 plus, because why? At time 6.7, okay, the ball B was was in air for 1.1.76. Why? Because it started sorry, it was in air for 1.7 seconds. Because why? It started 5 seconds later. So whatever the time of this one, we should subtract 5 to find time for B. Okay, yes, plus half negative 9.8, therefore 1.7 squared. I get a change in y of how much? It should be negative. Why? Because it is going downwards. 2.96 multiply 1.7 plus 0.5 multiply by negative 9.8 multiply by 1.78 squared. Then I get an answer of negative 9.129 meters. Now I want you to be in a position of interpreting. Okay, when the hot air balloon, when stone A reaches the ground, hot air balloon from initial, let's say the initial point is here. Okay, the initial point is here. When ball A strikes the ground, this one already had moved upwards, because it is not stopping, it is also moving upwards. At the distance of how much? Of 19.832 meters. This one that we calculated here, right? But now the stone was moving downwards. Stone B was moving downwards. Okay, at the instant the ball A hits the ground, ball B was still moving downwards, but now it traveled at a distance of how much? Okay, it was at time t 1.7 when ball A hit the ground, right? For ball B, its time it is going to be 1.7. Why? Because it is the time that ball A hit the ground minus 5, always minus 5, because now it is 5 seconds later. Okay, so at that time the ball A hits the ground, this one already traveled the distance of how much? Of negative 9.129. Actually, the displacement. Okay. So now we want what? We want the distance between the two. The distance between the hot air balloon as well as the as ball B. So now remember, the distance is just the distance, not the with these negative signs. So it means now the distance is gonna be this plus that, only the magnitude. Why? Because they want the distance or the height. Okay, they say what? Calculate the distance between the hot air balloon and stone B. So I'm gonna say the distance is gonna be now 19.382 plus 9.129. Every time when they want distance, you do not subtract anything, you always add. Okay, or a height. Okay, therefore we'll get an answer of 19.382 and a nice number of 28.96 meters. Like that. Like that. This is how you should understand this type of question. So the first mark is formula, any formula, then substituting that one. Here you can say it is plus, you can say plus half 6.7 squared is fine. You'll get a mark. Then you get a mark for substituting here. Then this is how much? 5 marks. Okay. So 1, 2, 3. Then here for saying time it is 1.7. Okay, you also get a mark. Get a mark for substituting, get a mark for saying time it is 1.7. Then you get a mark for adding both of them, mark for final answer. For 6 marks, it is like that. Okay, yes. Here you'll get a mark for substitution, for formula substitution, and concluding that the speed of that one it is that much. Then here it is 1 mark for formula substitution and answer. Like that. Okay, yes. Then let's look at the last question. They say on the same set of axes, draw a position time graph for both hot air balloon and stone A from the moment the stone is dropped until it hits the ground. So now use the what? Use ground as reference. So it means I'm expecting my trajectory. Remember, it's going to be like this. If I use ground as reference, so it's going to be like this. Let me try to zoom out that for us. It's going to be like this. This will be my position. This will be my time. So I'm expecting a graph like this. For A, I'm already sorted. It is the position time graph again. Position time graph, yes. So for A, I'm already sorted, because I'll say, okay, for A, I'll do this. Let me try to zoom out that for us. This number mang, 13.3. 13.3 I'll say, let us be in a position of saying, okay, this is position, okay, this is time in seconds, this is position in meters. Then where do they start? Where do they all start? Let me try to zoom out that for us. They start at a height of 200 meters, okay, above the ground. Anywhere, you can put it at that 200 anywhere, okay. Then what happens? Ball A goes upwards a little bit and goes down like that. Okay, but what happens? What happens with a ball? What happens with the balloon? The balloon continues to move upwards, okay? The balloon continues to move upwards. Let me try to draw that here. Ish. Let me do this. I want us to see something. So let me just put it the 200 here. It's fine wherever I put it, as long as I labeled, okay? This is 200. Remember, this is a sketch. It does not need to be precise in the measurement and all. This is what will happen to ball A, right? This will what will happen to ball A. Then the time here is 6.7. It reaches the ground, okay? Then now what will happen is that the hot air balloon will continue to move. So I need this. The hot air balloon will move upwards with whatever. Will move upwards like this until. Why? Because your night is continuing to move where? Upwards. Again, it is continuing to move upwards like that. So you just say this is the hot air balloon. Why? It is continuing to move upwards. It's instead of going down, it's changing. Why? Is increasing. Okay. Yes. Are we good? We are good. So now this is what we expected to draw. 1 mark for the graph, 1 mark for this one. Then I think for 4 marks, you needed to show or using ground as a reference. Another mark. Then now, from the moment stone is dropped, yes, then this time 200 meters above the ground. So that is all for that one. Okay, that is all for that one. So thank you very much for joining me. Let's meet on the next video. Thank you very much. I hope you enjoyed.